Per- and polyfluoroalkyl substances, collectively known as PFAS, can enter the groundwater in a number of ways. One common process occurs at firefighting training areas, where aqueous film-forming foams are repeatedly used. The PFAS infiltrates the subsurface through the vadose zone into the groundwater. The PFAS compounds are transported by the groundwater and can create plumes that may extend for several miles. These plumes can pose a risk to both human health and the environment. This creates an immediate offside liability to the site owner or polluter. PFAS plumes can extend onto residential properties or indeed entire communities, contaminating drinking water wells and even surface water courses. Injection of colloidal activated carbon at the site boundary can remove the risk posed by PFAS by preventing off-site migration and removing potential exposure. Plume stop is a liquid form of activated carbon, which floods the contaminant flux zones within the aquifer, removing the PFAS contamination from the groundwater and coating the aquifer material in a thin layer of activated carbon. Activated carbon is produced in large particle sizes for water or vapor filtration. Plume stop uses micro-scale colloids that allow simple, low-pressure injection into the formation. Activated carbon has a very high surface area, but in larger particles, many of the sorption sites would not be immediately available to the contaminated groundwater. By using colloidal activated carbon, better access to the sorption sites is ensured. The result is that when PFAS-impacted groundwater flows through an aquifer, which has been coated in colloidal activated carbon, there is a more rapid and complete removal of the contamination. Better access to the sorption sites is ensured. Sorption of the PFAS molecules occurs through sorption onto the activated carbon surface into meso or microfractures. Sorption of the PFAS micelles and sorption of the hemimicelles of PFAS. The aquifer now coated in activated carbon acts as a subsurface filter, removing further PFAS influx from the groundwater, which may come up from gradient or from back diffusion from less permeable zones. Taken in profile, plume stop is injected and creates a subsurface activated carbon filter. The permeability is unaffected, and so groundwater flows through the barrier while the PFAS contamination is removed through sorption. There are many types of PFAS compounds. Longer chain compounds like PFAS and PFOA tend to be more sorptive, and so it will be absorbed in the upgrade in part of the barrier. The less sorptive have shorter chain compounds, such as PFBA, will then be removed. The PFAS barrier has a chromatographic effect on the PFAS compounds, removing the longer chains first. The range of PFAS compounds moving into the next part of the barrier is now devoid of longer chains. This reduces the competition for sorption sites and allows progressive removal of the shorter chain compounds until remedial targets are achieved. Plume stop is a viable, cost-effective treatment approach for a wide variety of PFAS sites. Contact Regenesis to determine if plume stop is the right solution for your site. For more information on plume stop and effective approaches to treat PFAS contaminants, visit www.pfastreatment.org.